Hello, ladies and gentlemen. It's time for another AP Stats lesson with Mr. Green. Interesting picture, Mr. Green. That's a cat inside of a box. I wonder what that cat inside of a box has to do with AP Stats. Well, we'll have to look at it a little bit here when we get into the lesson a little bit more. What we're going to talk about today is the other day when I recorded this one, I gave you some information about the quartiles. I talked about finding the minimum value. I didn't talk about that. I talked about finding the median of the data. That was the quarter 2. And then the median of the lower half was the quarter 1 number. And the median of the upper half was the quarter 3. And then you have the maximum value. Notice how I've got 5 numbers here. The minimum, the maximum, the medians here of the different quartiles, okay? It divides the numbers up into 5, with 5 different numbers. It divides the numbers up and it gives you a boundary and where 25% of the data is located between here and here, and 25% of the data is between here and here, and 25% is between here and here. It is a good way of looking at data sometimes. And this is called a 5-number summary. Okay, so if you were taking a set of numbers like this one right here, you would actually find the median number, and it happens to be number right here, 26. That'd be the quartile 2. And we know the minimum number is 25, and we have to rank them in order. They're not in order in that list. I'm sorry. 24 is the minimum number, and 28 is the maximum number, and so our quartile 2 is at 26. So we find the halfway point between these two, and we see that it's 25 and 27, respectively. So our overall 5 numbers that we come up with are 24, 25, 26, 27, and 28. Boring list of numbers, isn't it? Well, you know what? That is a very compact list of numbers. Not very spread out, is it? Okay? So the 5-number summary is used to answer questions about percentiles. The percentiles are the percent of individuals that are at or below a certain value. So the quartiles are located every 25% of the data. The first quartile is the first 25th quartile, while the third quartile is the 75th percent quartile. Why are we doing this? You've seen this before when you've taken tests and they said you're in the 83rd percentile of the company, or 83rd quartile of the students who take this test. It is something that gives you a specific idea how far you are in the progression of things. Okay? So if they were ranked in order, the lowest to the highest, you'd be at 83. That means you're at your 83rd from the top, or you're 17 from the top, or above 83% of the people. Excuse me. Okay? So this interquartile range is the term that's used for that quartile 2 that's in between, that's from Q3 to Q1, that distance in there. It's 50% of the data, but it's just a term that is used there, and it's sometimes referred to as the interquartile range. Okay? So, box and whisker plots. That's what the cat was all about on the first screen. You're right. So here's another little kitty cat with box and with whiskers on it. So we're going to draw some box and whisker plots, or box plots. Why use box plots? Because it's a graphical representation of all that information. It's ease of construction. It's very easy to do. It's convenient handling of outliers. Its construction is not subjective like histograms can be, because in histograms you're trying to decide how big to make each range that you're going to do. That's subjective. Okay? This is very, very objective. It has no subjectiveness in it. It's used with the median or the large size data sets greater than 10. And it's useful for comparative displays. I can put 2 box and whisker graphs next to each other and tell a difference in the data immediately. Okay? The disadvantage of a box plot, it does not retain individual observations because it's just a graph, right? And it should not be used with data sets that are very, very small. I mean, it just doesn't make any sense. If you only got 10 people, it doesn't make any difference, okay? How to construct it. You find the 5-number summary, the minimum, the quarter 1, the median, the quarter 3, and the max. You draw a box from Q1 to Q3. You draw a median as a center line in the box. You extend whiskers to the min and the max. Seems pretty easy, and I mean, you probably have been taught how to do this a couple different times, okay? There's a modified box plot. In this one, it displays the outliers, okay? Those things that are a little bit beyond where we want to be looking. The fence marked off off mild and extreme outliers, and whiskers extend to the largest, smallest data inside the fence. Okay? Well, Mr. Green, in this class, well, I forgot about this. In this class, we'll always use this modified box plot. Why? Because we want the outliers being displayed so that we can see them. Okay? So here's an example. If I took the number that I had for the Q2 and drew a line, and then drew a box that included Q1 and Q3. There's my box. Well, I know that this number out here is I know that this is my interquartile range. It's got 50% of the data. This is what we're calling that fence here, right here. These are the fences. This is where the max and the minimum are, okay? Notice there's a point out here. That's an outlier. It's sticking outside of the fence, right? So any observation outside of this fence is an outlier. You put a dot out there for the outliers. Otherwise, you would just draw whiskers from here to there to be the whiskers. Okay? So, that's what we're doing here. We're drawing the whiskers in here for the quartiles, and this one, outlier. This outer fence out here is any observation outside of the fence is called an extreme outlier. We're not going to consider those right here because those are really outside of where we want to be. Anything that's inside of these fences is called a mild outlier. We're not going to try to make that distinction. We're going to say in the AP exam and in this class, you just need to find the outliers. You don't need to identify them as either mild or extreme, but that was just a little extra information just so that you know what they need, okay? Let's see here. This statement right down here, 1.5 times IQRs, interquartile range. Anything that's more than 1.5 times that interquartile range would be considered an outlier. Oh, that's how we're finding it. So if we start with this interquartile range, this 50% that's right here, and I multiply it times 1.5, anything beyond that 1.5 would be considered an outlier. That's where we're getting that from, okay? So here's the Department of Justice gave us the following percent increase in federal prison populations in 20 northeastern and midwestern states. Okay? In 1999. And you can see there's several sets of data here, and that's my calculator starting up. Go away. Thank you. So we got 5.9, 1.3, 5.0, 5.9, 4.5, etc., etc. It says use a modified box plot to describe the distribution. And we want to use a calculator to do it. How can we do this with a calculator? Ta-da, calculator. Okay? There it is right there. I'm going to move it down so that I can see the data here. I can't get it on the screen at the same time. So I'm going to do it this way. I'll push it over here to the side. What I'm going to do to begin with is I'm going to get out of this graphic mode. I'm going to push Stat, and I'm going to press Edit. So that's number 1 there. And I don't want L1 and L2, so I'm going to go up to L2 and I'm going to push Clear and Enter. And that'll clear out L2. I'll go over here and I'll go up to L1, press Clear and Enter, and it clears that out. Now I've got L1 sitting here. I'm going to enter the data in here in L1. Okay? So here I go. 5.9, enter. 1.3, enter, 5, enter, 5.9, enter, 4.5, enter, 3.5, enter, 7.2, enter, 6.4, enter, and I need to move over a little bit, get a couple more in here. 4.5, enter, 5.6, enter, 5.5, enter, 5.3, enter. A few more I need to get in here, so I'm going to have to move it off to the side here so I can get to them. You can't see me entering them, but you can see it right there on the screen. Okay, 4.1, enter, 6.3, enter, 4.8, enter, 6.9, enter, 8 point, enter, 4.4, enter, 7.2, enter, and 3.2, enter. Now you know what? I've got them all in. So I want to create a box plot. So what am I going to do? I'm going to press second stat plot. Here in this stat plot, I'm going to select number 1 because I want to change number 1 to be a statistics plot. I'm going to turn it on as a statistics plot, and I'm going to come down here. I want you to notice this one right here. That one right there is the one that is the, that one, not that one, not that one, not that one. That is the modified box plot. Right there. See how it's got the little dot out here at the end? That's how you know it's the modified box and whisker graph, because it'll show outliers that way. Okay? Cool. And it's using L1, which is where I put my data. And I'm going to press enter so that it's got all this in it. And I'm going to hit graph. And when I press graph, I got all this other stuff in there. I'm going to go back to y equals. I'm going to get rid of that because I really don't need that in there. And I can press graph again. And my data's there, but I really can't see it that well. So I'm going to do a zoom. And there is one for statistics. I believe it's number 9. I'm just going to scoot down here a little bit. Yep, it's number 9. See how it says zoom stat? If I do that, it makes it a nice big plot so you can see it on here. And look at what we got. A box and whisker graph. Box, whiskers, and there's even an outlier right there. So we got our box and whisker graph with outliers on it. Cool? Everyone see how I did that? Anyone confused? Watch it again if you need to see how it's done. I just entered the data in, and you can go through the steps to make a box and whisker graph. So let's look at some of these things. Here I've got histograms on one side and a box and whisker on the top. Looking at this information, well, this histogram, I'd see a couple of different points here, but if I look at the box and whisker graph, it almost looks symmetrical because I've got an equal amount of space here, and my whiskers don't seem to be any larger in distance. So I would say this one is called a symmetrical type of a box plot. You notice all 3 of these down here are listed as symmetrical type box plots. And guess what? It looks kind of strange when you look at the histograms comparing them to it, okay? Okay? But look at this one over here. This looks almost like a normal, looks kind of like a standard histogram, but look at how this data is kind of way over to one side here, okay? The Q2 is not in the middle of the area here. That means even though 50% of the data is in this little bitty white space here, it's still skewed over to the left a little bit. That's why you can see that with this type of graph, but not really all that easily on this one. Same sort of thing on this one. It's smaller on this side than on this side. That means it's skewed to the left this way. Okay? That's what they're talking about with box plots. It's easy to see that with a box plot, not as easy to see it sometimes in histograms. That's why we use the box plots to get this information. So looking at this information right here, we've got cancer and no cancer. I'm looking at two different box plots, aren't I? Right? And it says the median radon concentration for no cancer group is lower than the median for the cancer group. Well, you see this line that's in here? It's almost non-existent as far as the area between it and the Q2 and the Q1 are there. But you can see it's lower than this one up here. So I can actually look at this and see my radon numbers are lower just by looking at this one, by looking at these two box plots. Okay? The range of the cancer group is larger than the range of the non-cancer group. Well, yeah, I can see that. I mean, from here to there, compared from here to there. All right? Okay, both distributions appear to be skewed a little bit, don't they? Yeah, they're bigger on the right side. Yeah, and there's numbers going out this way further than there are numbers coming out this way. And the cancer group has outliers at 39, 45, 57. Well, yeah, I can't see where these numbers are, but I wouldn't doubt it that those are outliers. They're listed that way here. And this one only has two outliers at 55 and 85. But I can look at the box plot and get that information just by looking at the box plot. That's why we use this to help us describe the data. Now, what's coming up? We need to think about how we would respond to a question on an AP exam. How do you describe this data? That's coming up in a future lesson.